So once the modulus and the argument of a complex number have been established, then we are able to write that complex number in the polar form. For example, if the complex number z is equals to 1 plus I, then the modulus of z can be found as finding the square root of 1 squared plus 1 squared, which are the coefficients of both the real and imaginary part, which is root 2. And the argument of z is the arctan of 1 over 1. That is, thinking of this complex number to come from the Argand diagram, where this point is 1, 1. Then the argument is the angle that that complex number makes with the positive x-axis, that is that angle, where that is 1 and that is 1, because the imaginary part is 1 and the real part is 1. So theta is the angle whose tan is 1 over 1, or what I refer to there as arctan. And that in this case is pi over 4, which you might know as 45 degrees. So then the complex number z, which is 1 plus 1i, is now written as root 2 cos pi over 4 plus I sine pi over 4. That means it has a modulus. The modulus of the complex number is root 2 and the argument is pi over 4. Once we have established this, incidentally, this is sometimes also written as root 2 cos cis pi over 4. So instead of writing the whole expression cos pi over 4 plus I sine pi over 4, we tend to abbreviate that as cis pi over 4, and that's where that comes from, with the modulus still written on the outside of that. This is also sometimes written as root 2 e I pi over 4, which is referred to as the Euler form. We will talk about that a little later in the course, but it doesn't hurt to know that that's what it is referred to. Now, once you have established the CIS form, then we will be later on be looking at some generalizations that come from having complex numbers z1 and z2 both in the polar form. So say z1 is r1 cos theta 1 plus I sine theta 1, and z2 is r2 cos theta 2 plus I sine theta 2. And we will establish what happens when we actually multiply z1 and z2, and what happens when we divide z1 by z2 in terms of both the modulus and the argument. But that will come once we have done some trigonometry, and we'll be able to also prove that generalization by induction.